Hello everyone. Welcome to our next lecture of fluid mechanics and hydraulic machines. Today we are going to start our new topic that is the buoyancy and flotation. So let's start our new topic. In a previous session we had completed our plane surfaces which is submerged in a liquid. In that case we had seen about the horizontal surface which is fully submerged in a liquid. After that we had seen the vertical surface which is submerged in a liquid, and then after we had seen that the inclined surface which is again submerged in a liquid. So by continuing in this chapter, the topic and the new topic for this chapter which is the buoyancy and flotation. So let's start and let's see what is the buoyancy and flotation. First of all, here it is the some introductory session about the buoyancy. Let's see what is that. Here you can see that the one a ship model is there. Weight of boat, you can see that over here, that is the weight of boat which is due to the gravitational force, and that is the force number one which is applied by the boat. Okay, and second force, that is the upward direction force, and that is upthrust of water. This one is our second force which is applied by this water on the boat, so that this boat can float easily on the free surface of water. Okay, so whenever body is placed over the liquid like this, you can see that a boat which is a simple body and that is placed over the liquid, which is either sinks down or the floats on the liquid. So we have mainly two cases. The first case, that is the it sinks down. It means it sinks down over here in the water, or it can float like this boat. It can float on this liquid. So mainly there are two cases for this floating bodies. Okay, so two forces which involves for the cases for sink down of body, and the another one that is the float of the body. In that, the first force, that is the gravitational force, and which is the weight of body, that equals to rho gv. Weight of body, that is mg. You can say that the mass into gravitational force, that is the weight of body, and upthrust of a liquid, that is our second force, which is this one, that is upthrust of a liquid on that body. Okay, so mainly there are two forces which is applied on the body or by the body. If the gravitational force is more than upthrust, the body will shrink. Like, see, if you can see that we are having mainly two forces, and the gravitational force which is applied on this direction, downward direction, is more than the upward force, this upthrust force. At that case the body will shrink down to the liquid. So this one is our case number one, when your body will shrink. At that time your gravitational force G, which is greater than the upthrust force, and this one is our first case. And for second case, if your upthrust force, like this one which is acting in upward direction, if your upthrust force is more than the gravitational force, the body will float. So in our second case, whenever your upthrust force is greater than your gravitational force, at that time your body will float on the free surface of liquid. So there are mainly two cases by this figure. Okay, so this was a simple introduction about the buoyancy or the actual case which is acting in our real life. Here it is the some of the examples based on the buoyancy problems. First one, the bow instrument package or the anchor block, which is again sink in the fluid. This case is about for the submarine case, which can float on the free surface of liquid, or it can sink in the liquid. Ship model which is floating on the surface, and this one is a crane or the divine bell. So these all are the some of the example 2 and number 3, this one is number 4, and ship, that is number 5. So these are the examples of the floating body or the sink body which is totally based on the buoyancy. So now let's see what is the buoyancy and what is the basic principle behind that buoyant force. So everybody knows about the Archimedes principle. What is the Archimedes principle? It says that whenever a body is immersed wholly or partially in a fluid, whenever a body which is immersed wholly or partially in a fluid, it is bowed up. It means it is lifted up by the force equal to the weight of fluid displaced by the body. Okay. So in this case, we are having a case number 1 when you are having one this weight, one the dead weight which is outside of this container, and in the second case when you immerse this dead weight in this container, so there is a 3 pound of load which is applied on this dead weight, and over here that is the 3 pound of water is displaced outside from this direction, displaced outside from this container to this bucket, so that you can see that 3 pound of load is decreases. Over here it is the load of this dead weight that was about around 7 pound, and when you are putting this load inside of this container, at that time the load of this dead weight which is decreases by the 3 pound, and this 3 pound of water is displaced from this container to this bucket. Okay, so this is the our basic Archimedes principle, and it is said that when you are putting any body into the liquid, at that time the force which is applied on the liquid, which is equal to the weight of fluid, which is equal to the weight of fluid displaced by the body. This body is going inside to the water, and it will displace some of the water outside of this container, and this one is known as our Archimedes principle. Okay, so based on this Archimedes principle, we're having the buoyancy phenomena, and this one is the buoyant force. Let's see what is the buoyancy. A body in a fluid, you can see that over here we have one object which has a density rho. Over here that is the free surface of liquid which has a density of fluid, a rho fluid. Over here that is the rho object, m that is the mass of object, and g that is the gravity of this object, gravitational force of this object which is acting downward direction, and the bound force which is always acting on the upward direction. A body in a fluid, whether the floating or a submerged, floating body, it will again on the free surface of fluid, and submerged, that is fully or partially submerged in the fluid, is buoyed up by the force equal to the weight of fluid displaced, is buoyed up by the force, and which force, and this force is equal to the weight of fluid which is displaced by this same object. Okay, and the definition of buoyancy, that is the tendency of fluid to uplift a submerged body. It has some tendency of this fluid which affect and which uplift the submerged body because of upthrust of fluid, is known as the force of buoyancy or the simply buoyancy. So over here you can see that the force of buoyancy, due to this force of buoyancy, any body can float on the free surface of liquid, but whenever there is a increasing in the density of that free surface body, at that time it will sink to the liquid. Okay, so Fb, that is the buoyant force, that equals to weight of water displaced by the body. Buoyant force which is acting upward direction on the body, that will be equals to the weight of water displaced by the body. So buoyant force that equals to rho Gv. In this case the rho, that is the density of fluid, G gravitational force, and V which is the volume which is displaced by the fluid. Okay. So this one is our simple buoyancy. and buoyant force or the buoyancy which is acting at some place. So let's see what is the center of buoyancy. It means the at which location this force is acting on the body. So center of buoyancy is defined as the point through which the force of buoyancy is supposed to act. Like this, you can see that in this figure there is one CG which is the center of gravity for this body, and CB that is the center of buoyancy, and the center of buoyancy that is the point on which the force of buoyancy is supposed to act, and by the result of this force anybody can float on this free surface of liquid. As the force of buoyancy is vertical force and is equal to the weight of fluid, the buoyant force is equal to the weight of fluid displaced by the body. The center of buoyancy will be center of gravity of the fluid displaced. So you can see that over here it is the point of application for the center of buoyancy. Okay. So thank you. That was all about today's session. In this session, we had seen that the basic introduction of a ship when it is a floating or a sink in a liquid. Some of the example we had seen. After that, we discussed about the Archimedes principle, and which says that the force which is acting on a body and that will be equal to the weight of fluid displaced by the body. That is Archimedes principle, and based on that Archimedes principle, the buoyant force is acting on this object to suspend the any object on the free surface of liquid. After that, we had seen the center of buoyancy, that is the point of application of buoyant force. Okay, so you have to write all these things and submit that all the things by the Google Classroom. Thank you.